This video is going to go through half-life. So the first one, it says, how long will it take for 25% of the original sample? So since I'm starting here at 25%, well, here we'll go in 25%. What I know is I ended at 25%, I said, and I started 100%. So half-life, so half of 100 is 50, half of 50 then is 25. Each of these is one half-life, and the half-life for radon 222 from my table is 3.28 days. Each half-life doesn't change, but it takes whatever it is and chops it in half. So 3.28 plus 3.28 gives me 6.56 days. So that would be how long it would take. That's a pretty short half-life, so this decays away pretty quickly. You would say this is much more active. In terms of a graph, it would decay away much faster. Next one, how long will it take to get 6.25%? So again, I start at 100. I chop it in half to 50, chop it in half to 25, then to 12.5, then to 6.25. This is 1, 2, 3, 4 half-lives. 4 half-lives. Hydrogen 3's half-life is 12.3 years. So 12.3 times 4, and that's going to give me 49.2 years. So this half-life is longer, so it's going to be a little bit less active than the radon. So next one here, given this sample, and we have 1/32 remaining. So rather than starting at 100, 100% is 1. It's everything. So half of 1 is a half. Half of a half is a fourth. Half of a fourth is an eighth. Half of an eighth is a 16th. Half of an eighth is a 32nd. So how many half-lives did it take? 1, 2, 3, 4, 5 half-lives. So it took 5 half-lives, okay? And it took a total of 2,000 days. And we know each half-life is the same. So I'm going to say 5 half-lives, 5x equals 2,000 days. So if I were to solve that, I would say each half-life is 400 days. Again, I can divide both sides by 5 there, and I get 400 days for the half-life. Again, I know half-lives are all the same, and it took 1, 2, 3, 4, 5 half-lives. Next one, if the activity of a sample starts at 32 and ends at 1, so I'm just going to keep chopping this in half. So I started, and again, this unit BQ is a becquerel. We're just going to ignore that unit. And we start at 32 and I want to end at 1. So 32 goes to 16, which goes to 8, goes to 4, 2, and then 1. This is going to be 1, 2, 3, 4, 5 half-lives, okay? So this is 5 half-lives. I look at radon 222, has this half-life of 3.28 days. So 3.28 times 5. So 3.28 times 5, because there's 5 half-lives. And I'm going to end up with 16.4, I believe, 16.4 days. Okay, next one, 49.2 years. 49.2 years. Since it's hydrogen 3, the half-life is 12.3 years. So when I divide this out, I'm going to get 4 half-lives. So I'm going to start with my becquerel 25, and I'm going to decay it 4 times. So 25 goes to 12.5, 6.25, so that's 2 decays, 3.125. I'm going to get lazy here and say about 1.6, okay, because I'm getting a lot of decimals. And so this is 1, 2, 3, 4 decays, so about 6.1, and the unit with it is this becquerel, because that's what we started with. So big idea, if it's 100%, or if it's a percent, start with 100. If it's a fraction, start with a 1. If they give you some number, like 32 becquerels, just start with that and decay is the number of half-lives or until you reach the end point. Last one, if I have 1 mole of potassium 40, how many moles remain after 2.56 times 10 to the 9th years? So here, recognizing what that unit is, I look at the top, 1.28. So if I divided that out, 2.56 times 10 to the 9th years over 1.28 times 10 to the 9th, and I'm going to get 2 half-lives. So 1 decays to a half, and it decays to a fourth. The unit on this would be mole, so I would end up with 1/4 of a mole.